What's up, everyone? Welcome back to our YouTube channel. Today, we are merging the world of workouts and artificial intelligence to show you how to create your very own AI workouts manager. Now, let's take a moment to imagine a scenario. What if, instead of just logging your workouts manually or following a preset workout plan, you had a smart, intuitive program that not only tracks your progress but also optimizes your body goals, your body responses, and even your mood? It sounds like a dream, right? Well, it's time to wake up because we are turning that dream into reality today. Let's dive right into creating our first personalized AI workout manager. I'm going to start by creating a new project called Workout Manager. All right, so you can change the name to whatever it is you want. I'm also going to be having a GitHub repository that is tagged to this particular project, so you can see the full code once we are done. All right, so I just need to do two things. Number one is to ensure that the environment is initialized to where it's supposed to be. And the second thing is to test out this particular code to see if it is using the right environment parameters. So I'm going to first deactivate this, then I'm going to source it. So that way I have access to the VMV Python that has been initialized. If you look at the Python and you look at the bin, you can see uh, the Python here, which is linking to my Python. It could be Python 11, I think. Yeah. So if I do which Python, excellent. So it's using the right directory. So if you do Python main.py, excellent. We have IPython. So yeah, that means this code is working. Our environment is rightly initialized, and we can proceed. So I'm going to delete all of this. So before we continue, we are going to need to install a few packages. OpenCV Python, NumPy, CVZone, and MediaPipe. If you want to look at the documentation for OpenCV Python, CVZone, MediaPipe, and NumPy, you can see them here. OpenCV Python, OpenCV is a wrapper package for OpenCV. So this is using OpenCV C++, but it's wrapping it up in Python. So everything you can, well, technically almost everything you can do in C++, you can do with OpenCV Python. This is the Python version that is like a step above the C++ implementation. So you can see the code here. If you go to GitHub OpenCV Python, you can see it here. For the CV zone, it's also using OpenCV under the hood, but it's also using something very interesting called MediaPipe. MediaPipe is a Google implementation. You can see the implementation here. It's a Google package. So if you look at the API, you can see the the API reference, whether it's JavaScript, TypeScript, Android, or Java. You can see them here. If you look at the Python implementation, you can see, and you have some examples here that can do some object detection, image classification, landmark, gesture recognition, segmentation, and the rest. Yeah. So that is very interesting because this is still a new package that is being developed, and this is the early release. If you look at this, this is a preview and it's an early release from Google. So if you are interested, you can look through the documentation and guides. You should be able to catch up fairly quickly. All right, let's proceed. NumPy documentation. I didn't forget you. So if you look at the API reference, you can see the documentation for NumPy here, and you can do some manipulations with the arrays and the rest here. So you just look through if you need some clarification on any of these particular implementation here. The assets that will be used in the solution are copy pasted into the assets directory. So you might want to do the same if you are following through. The assets are available on the repository in the description below. We're going to import the MediaPipe as MP, and we're going to import NumPy as MP. Yeah, we're going to start with these ones for now. we need to have an entry point, which is going to be name equals to main. You don't really have to do this. This basically means that this is going to be the entry point once the code is being run by the interpreter. So you don't have to do it, but if you want, it's okay. Now, once we have this, the first thing to do is want to see what is inside this video itself. All right, so the first level is to be able to read the video and display it. So we have our cv2.video capture. So we're going to be capturing the video from assets and which is pushup.mp4. So I'm going to call this capture. So once we have that, and we are going to say if cap is opened, then we are going to have this because we want this to continuously read the video itself. So if the cap is opened, we are going to have the return response and then the frame from cap.read. Then if not right, if it is not true, because this is going to be true for each time it reads the frame, and it's going to be false when the video has ended or it couldn't read the frame itself. So we're going to break, and if the wait key, if cv2.wait key is hard, if you press q, then you break too. Since this is the same, or we press q, it should just, then the last part is cv2.imshow workout manager. Then we have the frame. All right, let's test it out. Perfect. So we are able to see the videos, and if we press Q, we are able to terminate. Okay. So this is the first step. Now we are sure our video is working as expected. The next thing we want to do is build on this. I'm going to comment this out for now, and we can now start the implementation of our code itself. So we have, we're going to import some packages, use some of the libraries, which is MP drawing from MP solutions, the drawing utils. Then we have MP pose is from MP solutions. That's pose. All right. So I'm going to have a function so we can put this in a separate little bucket. So I'm going to call the function called run pose detection. And I'm going to have MP drawing, the pose itself, and then the file name, which is assets pushup.mp4. All right. Now, to implement the function itself, we have run pose detection, we have MP drawing, we have the pose, then we have the file name. Then we are going to have our cap with this guy here. I'm going to move it into this guy so we can read the file from our assets file name. Okay. So once we have the cap, the same thing we did somewhere here when we were doing while true, this guy here, I'm going to move it here. This just shows us the video. We need to be able to process each frame that is coming in from the video itself. So we are going to have a different function called process frame, and this is going to take three arguments. We have the frame, we have the pose, we just pass it for now. We don't have any implementation yet. So if we are able to read the video. This is true, and we didn't press Q. We want to get the video itself. So we get the frame, process frame, which we pass in the frame, then we pass the post to it. I'm going to remove this. We want to go into this process frame, and then we want to extract, number one, we want to extract the dimension of the frame, and we do that by saying frame.shape. Okay, and this gives us the height, the width. We don't need whatever else is returned. Now, for us to process the frame, we are going to be using MediaPipe, the MP. Now, MediaPipe processes in RGB, while OpenCV processes in BGR. So each time we want to do processing in OpenCV, we process in BGR, but in MediaPipe we process in RGB. So each time we want to do our processing, so this is very key because if we don't do the conversion to RGB or BGR, we're not going to have the right result. So it's very important. So now we want to process in RGB, and right now we are reading the frame with OpenCV. So the first thing is to convert to the BGR model to image to RGB. Then we are going to have the image from the conversion is going to be cv2.cvt color. So the source is going to be frame. Then we are converting to cv2. So we are converting from BGR to RGB, this guy. And once we are done, we are going to be converting the image back from image color RGB to BGR. RGB to BGR. Is it? Color RGB to BGR. Excellent. Now, in between this, once we do a conversion, before we can use the image on MediaPipe, we have to make it unwritable. So we have image flags writable equals to false. So this will ensure that by the time MediaPipe is processing the image, it's not mutated, nothing is changing in the image itself. So we need to ensure the flag is set to false. And once that is done, we change our flag back to true. Now, inside this place, between the two conversion, we are going to process the image itself. So we have post of process, then we have the image. Then the result of the processing will be here. So we are processing the image with MediaPipe at this point. So at this point, we are doing converting back to OpenCV. Now, the reason why we are converting the image back to writable is using OpenCV, the image flag has to be writable so that you can place other make it like a canvas where you can draw and place other things on it. Without this, we are not. If it is false, we are not going to be able to place item on the image like text, images, and the rest. Then at the end of the day, we return we return the image, we return the results, we return the dimensions, which is the height and the width. Then I'll just copy this, paste it here. So this is the output of this processing. Now, at this point of processing, once we have the image, the result, the height, the width, we need to use these guys to calculate the angle of elevation. So by the time you are going down while doing push-up, we get the angle. When you go back up, we get the angle. And to do that, we need to do a little bit of housekeeping first to do the extractions of the landmarks, so we can detect your elbow, your shoulder, then your wrist. Those are the three angles that will form the top, bottom, and then the middle angle. So based on that, we can get the angle. Maybe it's 160, 180, depending on how we want to play on the angle of your push-up detection. So for us to do the extraction, we are going to have another function. We call the function extract landmarks. Landmarks. So for us to extract the landmarks, we are going to need what do we need here? We need the results from here. MP pose, not pose. Yeah. We need the results from there. The results from here. Then we need the MP pose, which is this guy, MP pose, that we pass in here. MP pose. I'll just put it here. Yeah, there's something that is actually missing here. Now, because we are going to be using MediaPipe in the frame, we need to have something here before we continue. So we're going to have with MP pose dot pose, the minimum detection confidence is 50%, then minimum tracking confidence is 50% as pose. Now, this will give us access to MediaPipe that we are going to be using to process the frame at this point. Yeah, that was an oversight from my hand. I just realized we didn't write this earlier. Yeah, so once we have this guy, we do the processing here, and we need the MP pose. Yeah, MP pose at that point. So we do the extraction of the landmark. We do a try catch, so we get the landmarks, which is going to be results dot pose landmarks to extract the landmark. Then we get the shoulder, which is the landmarks, MP pose landmark. All these things are contained in the documentation. If you are interested, you can look at it. So we get the X value, and then we get the X-axis, and then we get the Y-axis. So we can easily track the shoulder. Yeah, not X, this should be Y. And this is going to be landmarks. So we get the X and the Y. Okay. Anything else at this point? Am I missing anything? I get the post landmark, left shoulder, the value for the X, the value for the Y. Yeah, I think that's all. Then we do the same for the elbow. We do the same for elbow. This is going to be left elbow, left elbow, left elbow. Then we do the same for the wrist. So we have the left wrist, then the left wrist. So then we return. This is a try. We have an accept. We pass, and then we return the shoulder, the elbow. Then we have the wrist. All right. Okay, so we have the shoulder, the elbow, and the wrist. So by the time we do the extraction at this point, yeah, extract landmarks with the results. Okay. Say, oh yeah, this needs to go back. Yeah, it was tapped before, so why is this? Might be referenced before assignment. That is true, so we need to have shoulder equals to none, elbow equals to none, and then wrist equals to none. All right, I think that should fix it. Okay, so we have the results that were, and then we need to pass in the MP pose. Yeah. So once we extract the landmarks, we have access to the shoulder, the elbow, and then the wrist. All right. Now, based on this, we can now calculate the angle of your shoulder, your elbow, and the wrist. So that will give us the final results to know when you are up or down. So we need to do a calculate angle. So we pass in the shoulder, the elbow, and then the wrist. So this gives us angle. Not shoulder, it's shoulder, yeah. Then we just put it here. Def calculate angle. All right, so that gives us the shoulder, the elbow, and then the wrist. So what we need to do in this function is to get the distance between the shoulder and the wrist by subtracting the distance between the elbow minus wrist from shoulder minus elbow. We get the arctan function of that, then we convert the result to degrees. That's what we need to do. I hope that is clear. I'm going to fast forward that bit so we don't spend too much time explaining the mathematical functions. Once we have the angle, we can render the angle on the UI. So we just say render the UI with the image, the angle, and of course the width. The render UI function uses the image, the angle, and then the width. Okay. Yeah. So in here, we're going to be needing some few constants. So we have the angle max, the maximum angle we can go is 180. That's the angle we have here. That's the angle maximum. Then the minimum, where we want to say this is the cutoff. Once you reach this point, you are down. Once you go above that, you are up. So we are going to have the angle minimum as 25. All right. And this is going to represent the max angle when it's fully extended, and the minimum angle when it's bent. So we have CV2, we draw the rectangle for the image, but we need to have our definition. White is 255 in RGB format. We have the black, it's going to be 000, of course. The green is going to be 0200, 0. Red is going to be 00255. Then the blue is going to be specifically 245, 117, and 25. We don't want the dark shaded blue, but that specific type of blue. We draw the rectangle into the top center of the screen. So what we are looking at is to place the AI workout manager in a blue rectangle at the top of the screen. So we need to get the dimension, which is going to be the width and the height of the rectangle, as well as the location that we're going to be putting the text and the rectangle itself. So this is pre-calculated, so you can play around with it if you want. So we finalize by drawing the landmark image. We put in the results, pose, landmarks, MP pose, pose connections. Then we do the drawings for the specs, MP drawing. These are the detections that we have. Detections. So we do the drawing during drawing spec. So the color is going to be let's say 245, 11766. The thickness is going to be 2. The circle radius is going to be 5. I'll just copy paste this for the line and for the circle. So I'll do the same 244, maybe 66, and then maybe 230 for the thickness and the radius. Then we can do cv2.im show. Let's say AI workout manager image. Yeah, we already did this, so it's fine. All right, let's test this out. I hope it works as expected. Yeah, right. So we have our detections that have been rendered on the UI as the person is doing the workout, and we only have the workout manager rendered. So we need to render the counts as you're going down and up. We need to render that also. So I'm going to stop that. All right, so we change this back to AI workout manager. Okay. Now, when we are calculating the angle at this point, we have the angle. So we need to check the maximum angle that we have, which is this guy. So once we have the angle in here, I think we can also do something. We can adjust something here. We can say if angle is greater than or equals to 160. Then the stage, I'm going to put the stage here. Okay, the stage you are is up, and if angle is less than or equals to 25 and stage equals to up, then the stage is equals to down. All right. Okay, then instead of the only the angle, we return the stage also, and we can come back in here. Once we get the angle, we get the stage, then you can put the stage alongside here. In the render UI, we put the stage along. Then we can use that to render the text for the stage on the UI. So each time it goes down, we get the angle, we get the position it is, whether it's up or down, and let's see. So I'm just going to copy paste this. I'll just play around with this. This is going to start instead of this at the center. No, we start at the corner of the screen, and we just put this as 255. Then we call this reps. I'll put this as 15 just to put it a little bit down. Then half of this, actually complex 1, 2, 9, AA. Yeah, reps is the this is the stage, not the reps. Yeah, if I put that in and I try to run, let's see if it shows as expected. Yeah, we have the stage, but we don't have the position up or down. So what we want to do, I have the calculate angle here. This gives me the angle. I'll just move this a little bit out of here because it looks like I'll just move this out of here. So I'll say calculate and display angle. So I have the shoulder, the elbow, the wrist, the stage. Okay, and I'll paste this here. I'm going to be calling this guy here. So instead of calling it outside of the function, I'm going to be calling it somewhere here. Then I can have the angle. Once I have the angle, I don't need this anymore. The stage is there. Then I can return angle and stage. Okay. Now, so what I'll do, I'll make this stage. I'm going to remove this. Calculate and display angle. So I have the shoulder, the elbow, the wrist, and the stage. So I'll move the stage back to the constants here. So I'll call this the stage. It's going to be no. So it's easy for us to have. So if I do print stage. No, move it away from here. I'll put the stage somewhere here. Okay. Then if I run this again, let's see if it works. Up, down, up, down. Excellent. So it's working. So what we just need to adjust is we want to be sure and stage equals to, oh, yeah, we just need to do that bit. We don't have to, but it doesn't matter. So if you are coming from up, then it changes to down. This really is redundant, to be fair. Then all I need to do is when I'm rendering the UI, I render the stage alongside with it. So this is the stage text. So we just need to put in the value. I'll just copy paste this and I'm going to put the stage in here. I'll just increase the length, the position to maybe 95. And yeah, everything should be all right. Let's test this out. Yeah, up, down, up, down. So let's move it down a little bit. So instead of 95, we can maybe move this down a little bit to maybe 60. Yeah, down, up, down. Okay, perfect. So what we just need to do is by the time we get this guy, we don't need to print anymore. We are done with the calculate and display angle. So we have our angle marks. So we now want to, at this point, we want to calculate the, each time it goes down, we want to be able to increment the value. Just like we did for the stage up and down, we want to calculate the value. So if you go down in here, we have the stage. Let's put our counter somewhere here at 0. So that by the time we are calculating and displaying the angle, we put in our counter. Once we have the angle, yeah, we put in our counter somewhere here. And so if you keep going down, we just increase the counter plus equals to 1. Counter equals to counter plus 1. And then we just add our counter somewhere here. So we return counter. So you just keep increasing. Yeah. So the stage returns the counter, and then we can put in our counter somewhere here in rendering of the UI. We have the counter. Then we just do the same thing we did here. We just do the same for, we need to move this stage a little bit further. So let's move it to 95. And then for the reps, which is going to be our counter, the reps is going to be str counter, and we are going to put that in 15, and everything else should remain the same. 15, we move it forward by 95, and everything's okay. So let's check it out and see. Reps. All right. So what we want to do is we want to keep, it's only when it crosses the threshold that we want to keep increasing. We don't want to keep increasing each time it goes down. So there is a little bit of error here. So instead of less than or equals to, it should be just, so once it is greater than this, we change this, and once that is greater than that, and then the stage at this point is up. So maybe that is useful after all. Let's see. Okay, 1, 2, 3, 4. Excellent. So you up, down, up, down. Okay, good. For the progress bar, what we want to do is we want to normalize the angle that we get, which is the one that we printed earlier, to values between 0 and 100. So even if the value is greater than, let's say, 180, for instance, the value remains between 0 and 100. So we're going to use the min max normalization formula to do that. That gives us a variable, a value between 0 and 100. We might need to fine tune the maximum depending on if the progress is a little bit above 100 or not. So we'll see shortly. Then we just render the same in here. So the first part that we're going to be rendering is a rectangle that represents the progress. So which is cv2.rectangle. We put the image. We put the image in there, the position we want it, and I'm going to just type in some pre-calculated values here. Progress times 2. Then we put in 370. It's going to be green. Then we fill it up. cv2.filled. We are going to do the same for the border. So this is going to be white. Just put 2 there. But instead of increasing this, we have a maximum value, which is 250, 370. Then we just put in the, yeah, the, yeah, we just put that. And we can, yeah, for the final part of the percentage, we have CV2. I'll just copy this, put text, add a rectangle, this guy. So I'll just change this up real quick. Percentage. Okay, I'll put this in 50 by 400. All right. And that should give us our percentage and progress bar. Nicely. So as it's going down or up, we keep calculating that. All right. So that gives us access to the progress bar. So this is going to be display time. And somewhere around here, once it is the UI is rendered, we have image equals to display time. we are going to have our image, the start time, which we don't have right now, the height, and then the width. All right, so the start time, we are going to import time for that. Import time, and then once we run the run post, I'm just going to minimize this guy. We're done with this, done with this guy, done with this. Okay, we're even done processing the frames. So what we need to do is in here we do start time equals to we get the initial time. So that gives us the start time that we can use in here. So we can copy this for the display time. So we get the elapsed time, which is the time, the difference between the current time and the time was started. So we're going to have time minus start time. Then we can get the hours, the remainder. So there's a function called div mode, elapsed time, then convert it to hours. For the minutes, we have the seconds. We do the same, div mode. We get the remainder by 60 to milliseconds. The milliseconds, we have the difference between the seconds and seconds times 1000. This gives us the milliseconds. It's easy to just represent that in a string format. So we get the hours, minutes, seconds, and the milliseconds. The position where we'll be putting it is going to be the integer division of the width divided by 2. Then we move it forward by 200. Then the height is going to be, we are going to be dividing the height by 2 also, the half divided by 2. That's the center of the screen. Then we just put the cb2.putText on the image, the elapsed time in string format. We put it in the position, then cb2 font face, which is the font Ashley Simplex. The scale is 1, the color is white, the thickness is 2, and then cv2.line AA. We just return the image, and voila, this should solve our problem of time. So if we rerun this, we should have the time running. Okay, so the time is running, but keeps the milliseconds is not correct. So I have the seconds minus that multiplied by 1000. Yeah, I think this is where the issue is coming from. Yeah, that is okay. All right, so finally, we need to render the clock. So to render the clock, we are going to display clock icon. So we have the image, we have the display. It's not alarm, it's clock icon. So we're going to put the image. We're going to be needing the path, which is the assets / clock.png. Then we need the height and the width, where to place it on the screen. The clock icon is going to be read using IM_read from the icon path, which is what we have right here. I'm just going to copy this. Change this to icon path. Okay. Now, once we read that, we are going to have a maximum size for the icon, which is we have 500 by 500, but we are going to have the width and the height. So instead of that, icon width is going to be, let's say 375, then icon height is going to be 200. Then I can have clock icon replaced by clock icon CV2 resize. Then I need to pass in the clock icon itself, then the destination size in a tuple of width and height. Okay. What is left at this point is to calculate the offset of the clock icon and the position we are going to be placing it on the UI. I mean, on the frame itself. So we want to place it behind or above the timer that is currently running. But it is important to maintain the transparency of the icon itself. So we want to check the shape of the icon to see whether it is 4. If it is 3, it is not transparent. But if it is 4, it is transparent, I mean the shape. So once we do that, we get the alpha icon, the alpha image, then we loop through to render the rest of the shape on the UI. So going back to this guy. So going back to this guy, I have the asset clock, and then if you run this again, operands could not be broadcast together with the shape of 720, 180 and shape. Okay, so let's see what is happening there. Yeah, this is icon width and icon height. Yeah, it fits nicely. We've come to the end of today's session. If you have any comments, please drop them in the comment section. You can check the link in the description for the code and the asset. Thank you very much for watching, and see you next time.